Hello and welcome to the last week of trigonometry stuff. I mean, our last kind of full week, and we're going to be, ending things here on Friday. So, kind of the last big topic that we have here. We're going to take a couple days to go through that. A little bit more on Wednesday, and then Thursday and Friday is just going to be some review stuff. A couple of questions from each chapter. Make sure you go over those things, and then that'll be it. And you guys can always go up to the school. I think they're going to have time slots, whatnot, that you guys will get or have information on, or will be getting some about when to bring those types of things in. But what we're going to be doing today is we're going to be looking at a different operation on complex numbers. You guys have looked at adding them, subtracting them, multiplying, dividing. So the last kind of algebraic operation that we have to do here is exponents. Okay, and so we're going to take this a little bit to kind of see why does this work, and then I'll show you guys how this works as well. So if you want to skip ahead a little bit to see just how it works, or you certainly can. But I'm going to show you kind of why it works here as well, because here if we have this complex number 2, remember this is cosine I sine, cosine 30 degrees, I sine 30 degrees, but I'm going to shorthand it because I don't want to write that over and over. So here if we have to the 4th power, this is repeated multiplication. So really what this is this 4 times over. Now I'm going to type it out. 1, 2, 3, 4. Okay, that's what that is equal to. And now you know that when you're multiplying complex numbers, that's from last week, we can take these first numbers and multiply them. Now we can go 2 times 2 times 2 times 2, right? So I'm going to bring these all in. Here we'd have 2 times 2 times 2 times 2, which is 2. And I'm going to write this here for a second, 2 to the 4th, right? And then we would also have 30 plus 30 plus 30 plus 30 because we add their angles together. It's sort of like a rotation. We're kind of rotating things around. So this is, we're rotating by 30 4 times over. So I know that you guys could add those together. Oops. Dot. But I'm going to put that in there just for emphasis, right? What's happening here. So then we could finally evaluate and say, well, this is 4 times 30 is 120, 2 to the 4th being 16, right? And so there's our final result, 16 cis 120, or 16 cosine 120 plus I sine 120 in there. But here's where I want to focus on, right? This spot right here. Because we can see, oh, actually this exponent shows up on the 2. It sort of got distributed in a sense to the 2, and it also got distributed to the angle, but again, it's a rotation. We add those angles together. So really this is just 4 times 30. That's what this number got multiplied times here. And that's it. Like that's the whole thing of exponents of complex numbers. Yeah. And to put this, it looks really complicated, but really that's all it is. This is called de Moivre's theorem. De Moivre's theorem. It's tough for me to pronounce. So if you want, there's a little video link on here too, that if you really want to know how to pronounce it, you can follow that. But all it's saying is that if we have a radius, right, or our distance away, right, or our absolute value, sometimes we call that 2. I call it a radius. It's kind of like going around in a circle. We just take that to the n power, right? And then the inside just gets multiplied by that n. And that's it. That's the whole thing, right? That's when we raise something to a power. There's a little bit more to it that we'll go over tomorrow. Like if we change this, to fractions and things like that, well, there's some updating that we have to do. But for right now, we're just going to basically take this, if it's a whole number power. So I'm just going to do a couple examples. If this is making sense to you, you want to jump to the homework, you certainly can. I'm just going to do a couple examples. So for example, here, if I had this one, and what I would do is I would say, well, this thing here, let's clear this stuff out of here. I would take the 3 and bring it down to the 8. So that'd be 8 to the 3rd power cis 3 times that 65-degree angle. And then you use your calculator to figure that out. We might be able to figure out some of that. I don't remember what 8 to the 3rd is off the top of my head, so I got to double check that. Happens to be 512, and 3 times 65, well, I suppose 3 times 60 is 180. 5 more is 15, so I suppose that's 195 degrees in there. and then we're done, right? That's all there is to it, nothing too much. So there's step one, and there's step two. That's on de Moivre's theorem. Here I'm just going to show one more example, right? If we had this thing, again, same type of thing. Here we would go 5 to the 4th power, and here we would go 4 times 200 degrees, right? I'm not going to put the degree symbol in there because it takes a little while to type that in. But in here, right, same type of thing, 5 to the 4th, not too bad. I forget what that is off the top of my head. Something times 625. Oh, no, it is 625. Whoopsie daisy. Okay, 625 there. And then 4 times 200 is 800 degrees. And now, but there's one more little piece here, one more little piece that we're missing, because this 800 degrees is more than 360. So what we could do is keep reducing that by 360 degrees until we get something that's smaller than 360. So here we could take, take away 360, take away another 360, or you could have thought too, hey, let's just take away 720 degrees. This is the same as, actually, I'm going to put both of those steps in there. Remove 360, remove 360 again. All three of these are technically the same number. All three of these bottom ones here are all the same number. They're all three the same. They're just, an extra spin around the circle, right? We, spun around the circle a few times. So this very bottom one is the most simplified one. And so that's the one we'd want to keep, where we do that reduction there. But that's how you can work with de Moivre's theorem. And tomorrow we'll look at a little more in depth of another piece that goes on. What if we have kind of fractional powers up there? But for right now, that's what we do with those. We just bring the power down, bring this inside, multiply, and reduce the answer if we need to. So let me know if you got any questions. Otherwise, good luck.